you can see how the CAE market has evolved, at least for FEA. It led to the growth of some of these pre-processors, which are offered by companies. Quote unquote, being multi-solver mean they take these text-based approaches and make it easier for the customer, which is good in a way, but it also, I think, has its drawbacks, right? But the downside of just using, let's say, standalone pre-processors, which are kind of a generic tool, which can do one solver and the other, is that you miss out on the latest and greatest. The only, let's say, provider that can guarantee that kind of integration that is responsible for developing both.
Yeah.
And that's really our focus. We're doing some fun stuff with Nastran. And the more I learn about it, I realize, whoa, you guys did that well before XYZ. You had topology optimization in the 90s? Wow, I didn't even know that. So just finding a way to expose some of this and also innovating on top of that has been a fun journey for everybody in the team. I needed to share this because that's exactly what I love about Hexagon, is that so being able to work for a company that knows how to make products makes it easier, because we are focused on manufacturing. Like every industry out there, whether it's aerospace or automotive, at the end, they're all manufacturing. So we are able to relate much better, not just from a design perspective, but also from, hey, can I make my as designed part and my as manufactured part work? And given what we have in the rest of the Hexagon portfolio, which is through, let's say, metrology, through production services, etc., we are seeing the huge benefits out of that, where we are not only able to take simulation down to the shop floor, but also take some of the inputs to CAE. Okay, that's one of the major strategic reasons for why I think D&E and Hexagon make a lot of sense.
People talk about future development and how things are going to change, and AI, machine learning, it's everywhere. But if you don't have the fundamental foundations in terms of building models, running models, verifying models, if you don't have that aspect right, then nothing's going to work from there, is it?
Core of product development depends on the accuracy, the robustness that these high-end solvers, whether it's from us or anybody else, brings to the market. Today, for the most part, the way it gets used on people's desktop is through a very text-based, keyword-centric approach. What Apex did was solve the direct modeler issue 10 years ago or 8 years ago, as you said, right?
Yeah.
By saying, I'm going to make it much easier for you to take a CAD and mesh it, do mid-surfacing, do all the ties, etc. People loved it. And the benefit that tools like Nastran and Mark bring is that for people have been designing aircrafts for 60 years. It's validated, tested, verified. Gazillions of products are in the market using these tools. We made some choices. Now let's bring them together, because FEA is a sticky product. It's not going to go away. Engineering depends on it. Whether you want to send somebody to Mars or you want to put them in the next EV, we're just trying to make sure we see the new needs, requirements, which are essentially a modern tool like Apex has, but then blend it with, let's say, deep tech. Thank you for what you do for our customers and users with the courses that you built around Apex and FEA. Yes, you're using Apex, you're using Nastran, but for anybody who wants to learn FEA, I think the way you structured your class is much better than how we do it or anybody else does it, because we are trying to sell Apex, we are trying to sell Nastran, but you are, on the other hand, trying to educate people on FEA. Kudos to you for the effort you do it. Hopefully, we get to see a lot more of that from you coming with using our products.
Subham Sett is an experienced and highly skilled engineer and product strategist with over 25 years' experience in engineering simulation. Based in the Greater Boston area of the USA, Subham completed a bachelor's degree in mechanical engineering in his native India, followed by a master's degree and PhD research at the University of Colorado, Boulder. Following a period in development at an RF communications startup, Subham spent the next 17 years at Abacus and Dassault Systèmes, with various roles, initially as a technical support specialist, up to VP of Marketing and Strategic Initiatives around nonlinear FEA and its adoption in industry. Today, Subham is the VP of the Multiphysics group within the Design and Engineering organisation at Hexagon. Here he drives future strategy and technical innovation around a portfolio of structural FEA and related solutions, supported by a team of highly skilled simulation engineers and product specialists. In this conversation, we explore the many facets of the current and future simulation software market, the need for better integration between the user experience and deep solver technology, and guided by Subham's mantra, build better, solve smarter, we examine how Hexagon is nurturing the relationship between simulation and manufacturing. Cool. Let's go. Let's get started. Thank you, Subham. Good to see you today. Before we get stuck in, you're based in Boston, Massachusetts.
I'm based in the Boston area, Greater Boston in Rhode Island. Haven't moved since the last 2 decades.
Okay. Sounds
I work
good.
for another company which is based there. That's all I'll say right now.
Yeah, gotcha. I think I know who that company is. Okay, so you are, I'm just checking out your LinkedIn profile, VP, well, your title is VP of the Multiphysics group for Hexagon. Yeah. So you're involved with lots of products, lots of people, lots of development and what have you. Just wondered if you could perhaps give us a concise or just fairly short background to your academic studies and the jobs that you've held since academia through to where you are now.
Thanks. It's going to take me down the memory lane, but I'll try and keep it short.
That's good.
So I did my undergrad in India at the Indian Institute of Technology, and I moved to Boulder, Colorado to do my master's/PhD in the area of microelectromechanical systems and electronic cooling and packaging. My background was thermal.
Yeah.
But as happens with every let's say academic pursuits you have, you look at what you're working on and you see what some of the opportunities are out there. And after my master's, I actually got an offer to work at a MEMS startup company designing RF micro devices, MEMS devices.
Yeah.
And I got hooked in the first week when my boss then said, hey, you know, the ideas you're proposing are patentable. Why don't you start writing them down? So 2 years right after my grad school, I was focused mainly on design and development of RF MEMS devices, which was part of the, let's say, mobile system, which made its way into mobile devices for switch arrays. But that also exposed me to Abacus a lot because we were using Abacus for the structural solver when we were using it in conjunction with electrostatic modeling. A friend of mine was working in the Providence office of what was then HKS. So I interviewed, the way I joke about it is I interviewed as HKS and I joined as Abacus.
Okay.
And there I got exposed to the whole wide world of CAE. Till then I was doing product development, actual products. But then I started using software and making sure the software meets the industry needs. And to me, having that industry experience grounded me a lot. So I didn't come at it as a numerical guy. I came at it as an experiment, as a person who's developing and designing a product and being practical about it.
Yeah.
So through multiple roles, which started in support, I looked at fluid structure interactions. Again, the MEMS background for me kind of set me up for fluids because it was more of a multiphysics application when we were working between Fluent and Abacus. And a few years into that, we actually set up our whole multiphysics strategy at what was then Simulia, because Dassault had acquired Abacus and had rebranded that as Simulia. Did that for a few years, and then life sciences opened up as an area that the company wanted to invest in, and they wanted to go into that area. And my exposure started expanding beyond just technology to industry, with a focus on some of these emerging markets like life sciences. The good thing with all of these transitions were the technology piece was always strong, which meant that I was going to conferences, we were submitting abstracts, we were working with professors in academia, and the urge to get technical publications continued till about, let's say, mid-career for me. Moving forward a few more years at Dassault, where I was looking at many of the new things that you've seen come out of Simulia, whether it's additive manufacturing or things to do with, let's say, newer technologies, things like eVTOL, etc., were being done in my team, where essentially we were almost like the avant-garde team. where you're looking at new tech, new industry, seeing what the best, where there is growth opportunities and where our products can actually fit in, but also at the same time identifying gaps. And additive was one of the best experiences we had in it at the team, because it meant going all the way from design to manufacturing and working across all the brands at Dassault, the design side all the way to production with the Delmia solutions. That was a fascinating experience. I then decided to take a gap, a couple of years, was working on my startup, nothing to do in this field, and then I joined Hexagon in 2021, late 2021, and it's been a fascinating ride for me because I've been exposed to, I'm going to say, one of the world's oldest and yet most trusted structural solver, which is Japan. But at the same time, the Multiphysics portfolio is much more than structures because of the work we do on the acoustic side, the work we do on the cradle, on the CFD side, and finding a way to bring that entire product group together, whether it comes to product releases, working on solutions, or even talking to customers, has been a fascinating challenge to solve. So in a way, in a nutshell, I like thinking of myself as a technology geek who cannot geek out as much. The team geeks out, but I like to challenge them with new things. And hopefully the market is starting to see some of that coming out of Hexagon.
Okay. So I was obviously involved with MSC before the Hexagon acquisition, so there's lots of new technology become involved. Do you know, or have you ever counted how many products you and your team cover within the Multiphysics group?
So let me look. So by far, the structures portfolio is the largest. I think we've got 6 products there, 5 or 6, starting from pre-processing, solve, the entire gamut from linear to non-linear. As well as let's say the thing that I don't cover within the team, but I think it's important to mention that when somebody is using, let's say, additive manufacturing from Hexagon, whether they're using Simifact tools, etc., we are the engine behind it when it comes to the structural solvers. So the go-to-market there is with, let's say, Simifact, but the engine behind it that is Mark. Something people, not necessarily everybody, know about. So we are technology providers to our internal teams, through which products get released, and we also put our products out for the general CAE market. And then you take what we're doing on the acoustic side and the CFD side, give or take, I've got 8 to 10 products that we actually sell, whereas there's about 2 to 3 products that we provide technology to.
Yeah. Okay, so potentially a bigger portfolio than what you would have seen with Abacus or Simulia then.
Yes, it's bigger, it's older, which also presents its challenges, of course, because technical debt can be an issue when you have a large portfolio that's been around for a while, which is why this has been a fascinating journey, because you can take the best portions of the technology and expose it in a much modern manner, which is true. As you probably use Apex a lot, you can stand by it. Tools like Apex are really the way people should be looking at Nastran. And this journey of bringing the two together, which I'm sure the world has started to see from us, is making it easier for, let's say, our users, as well as prospective users to enjoy simulation or consume simulation.
Yeah, that's a big factor. I remember using Abacus myself in my early academic studies. Or
give me a star keyword. Come on, Steph. Give me a star keyword.
I can't remember. I've got the book on the shelf up here, but I've mentioned this many times that you could prop up a table with the the documentation.
I have those still at home. I have the that my son uses for his project work.
Yeah.
But you're right. They may be paperweight, but they're also, I'm gonna say, golden. For anybody who wants to get into FEA, right? It's really very well documented.
Yeah. But I was introduced to that software on my own. I was trying to learn it myself. So it's pretty difficult environment, Obviously, when I got involved in Nastran, I was surrounded by lots more experts, that could help out with stuff and what have you. So yeah, the point of entry into those legacy tools, whether it's Abacus or Nastran or whatever, was much more difficult than with some of the the contemporary. I mean, people talk about next generation, don't they? I mean, people have been saying next generation tools for 20 years now, haven't they? But it's it's obviously
it's interesting stuff that you bring this up, right? So you can see how the CAE market has evolved, at least for FEA. And to some degree, it's happening on the other side as well, CFD and other domains as well. It led to the growth of some of these pre-processors, which are offered by companies, which quote unquote being multi-solver mean they take these text-based approaches and make it easier for the customer, or let's say the user, to use.
Yeah.
Which is good in a way, but it also, I think, has its drawbacks, right? Is in the sense that, and that's what we're trying to address with what we're doing with Apex and Nastran, is the fact that there's a lot of tech, and you know this from your Abacus days as well. Not everything in Abacus was exposed through Abacus CAE. I personally had to go in and do input file editing in the CAE file. So there was a need for these pre-processors. But the downside of just using, let's say, standalone pre-processors, which are kind of a generic tool, which can do one solver and the other, is that you miss out on the latest and greatest. The stuff that, for instance, again, let me bring up the Mark Mentat topic. We had an internal meeting with Axel Products. They talked about how well Mentat and Mark are integrated from a user experience perspective so that you don't miss out on anything in Mark.
Yeah.
The only, let's say, provider that can guarantee that kind of integration that is responsible for developing both.
Yeah.
And that's really our focus moving forward, Steph, is to say, we're doing some fun stuff with Nastran. It's a 60-year-old product. Yes, I get it, but it's also very well revered. And the more I learn about it, I realize, whoa, you guys did that well before XYZ. You had topology optimization in the 90s? Wow, I didn't even know that.
Yeah.
So just finding a way to expose some of this and also innovating on top of that has been a fun journey for everybody in the team.
Yeah, that's an interesting point, isn't it? That the sort of generic pre and post tools that will serve lots of different solvers, there's naturally going to be a lag in terms of their direct support. Whereas if you've got, like you say, if you've got a tool, take Mentat as an example, Mentat and Mark workflow, you've got almost a sort of forensic level of detail through Mentat straight into the solver capability, solver controls, which you perhaps wouldn't have with other things, Yeah, okay.
So and you're Apex, absolutely right.
Yeah, Apex is going that way in terms of the Nastran workflow.
Exactly. So the best example you have there, which was released not this release, but before, was on the module side, right?
Yeah.
If you look at what we've done with modules and the excitement we are seeing in the user base is fantastic. People have said, hey, it's just, instances, it's parts, etc. It's like, no, it's more than that, because now it is so well integrated that, you can literally think about your workflow instead of thinking, okay, what element ID do I need to bring in to connect with another part?
Yeah.
Oh, I've got a model sitting here. How do I get it here? Plug and play. Yes, you could use include files, but that's a lot of work. But now Apex and Nastran are pretty much in sync on that topic, which makes it much more easy. And we're seeing that excitement in our customers too. When they see it for the first time, they're like, oh, I can bring this here now from my other model. Well, other codes, softwares have had it for a while. We've had it too, but it's not been exposed in that tightly, let's say, combined manner till now. So that's what gets us excited.
Yeah, gotcha. Okay. So, I mean, we've covered a few aspects there of software development and workflow and ease of use and capability and what have you, which probably some of the questions I was going to come on to, but that's good that we've covered those. So, you've seen other CA vendors. You've worked for Abacus, Simulia. You're familiar with the other tools. In terms of the things like product development and future strategy and penetration, How do you think Hexagon, both in terms of the design and engineering division,
Yeah.
which is more traditionally focused on the FEA and the CFD software, how do you think Hexagon compare with other CAE software providers?
So, okay, that's an interesting question. That's one of the questions that I'd asked, the team when I was joining, is to say, why do I want to work for another CAE company? I've worked for one of the best companies in the world. Why now? They said, why don't you join, start seeing what we have in the portfolio, and then you make up your own mind. I needed to share this because that's exactly what I love about Hexagon, is that being a company that makes its own products, having that manufacturing base, knows how to make actual products. And if you go back to what I said earlier, I come from the world of actual product development, not just simulation. So being able to work for a company that knows how to make products makes it easier, because we are focused on manufacturing. Like every industry out there, whether it's aerospace or automotive, at the end, they're all manufacturing houses. They're making something. So we are able to relate much better, not just from a design perspective, but also from, hey, can I make my as designed part and my as manufactured part work together? Feed forward feedback loop. And given what we have in the rest of the Hexagon portfolio, which is through, let's say, metrology, through production services, etc., we are seeing the huge benefits out of that, where we are not only able to take simulation down to the shop floor, but also take some of the inputs to CAE. So I wanted to start with that, to say, okay, that's one of the major, let's say, strategic reasons for why I think D&E and Hexagon make a lot of sense. The second one is the team. We have a new management team, right? So from all the way up to the CTO, to the general manager for D&E. We came in new to the company maybe 3 to 5 years ago. And the whole goal is to say, hey, can we go back to the basics? Yes, there's a lot of chatter around AI, machine learning, etc. But what is the fundamental basic? What does the user need to do? Just identifying that, working with users, talking to customers, and finding what their pain points are, and giving them what they need to do today by keeping an eye out on the future, is something I think we are starting to do better.
Yeah.
And it's showing up. And again, you can speak for yourself, because you're a consumer of Nastran and Apex. I think it's showing up in the product qualities that are coming out as well. That's getting into the hands of our customers now.
Yeah, I mean that
Apex,
sorry, I was going to say that. I mean that's key, isn't it? People talk about future development and how things are going to change, and AI, machine learning. It's everywhere. It's all over LinkedIn and what have you. But if you don't have the fundamental foundations in terms of building models, running models, verifying models, if you don't have that aspect right, then nothing's going to work from there, is it?
And Steph, that's a very interesting point. So I think in the CAE world, I can speak for myself and my team and whoever I speak to. There's a lot of fear, right, and angst to say, hey, is my job going to go away? Because AI is going to take my job, etc. But the thing is, at the end, it's just a technology and a tool that makes you much smarter and more productive. If you take that lens, it still needs to your point, it needs to be fed the data. Yes, you can use all your legacy data, whatever you've captured throughout the years, and you can come up with your AI agents that help you design faster. But now let's say you take the FEA component out, or the CFD. And I'm not speaking just for Hexagon. This is in general.
Yeah.
Take FEA, take CFD out. At some point, you're going to lose that data. At what point do you say 1 + 1 = 2 versus 1 + 1 = 1.99 with a R factor? No. You need that engineering. That's
absolutely. Yeah, okay. So we talked a bit about the software market, and there are new technologies coming out all the time, from some of the traditional vendors and some of the newer companies, startups getting seed funding, lots of noise around that kind of stuff. But if you think back to the core of the Hexagon solvers we've talked about, so Nastran and Mark, obviously. I mean, Adams is there as a multi-body solver. How do you think the market views those legacy tools? Do they see them as old-fashioned, or do they, is that the thinking, or do people really understand that having that that legacy is such a powerful thing in terms of serving the market?
So, very interesting question. I would have put myself in that bucket 2 or 3 years ago when I looked at Nastran and Adams. But when you're in the inside, you get to look at it and you realize you've got hidden gems. As I mentioned earlier, people are getting investment funding for stuff that was probably done 30 years ago already. It's just that awareness is gone, right? It's been there for so long, you don't pay attention. And of course, the new shiny object is what gets the attention. So to answer your question, yes, there is a little bit of that, but it's also tied in with, let's say, a transition that's happening in the workforce, right? So the workforce don't just need tech. They need a way that they can consume the technology, whether it's through new user interfaces or even, a cloud-based approach to, looking at diagnostics, etc. The challenge and the trick is, how do I find a room for both so that I can resolve the technical debt? Because if I think of a large entity that has invested in, let's say, whatever technology, whether it's Adams or Nastran, they have, let's say, 30, 40 years of legacy data. What becomes our job is then to say, hey, that we are also going through that same challenge ourselves as software developers, right? We've got code written 60 years ago that nobody's there to manage. How do I take that code and go to the future with a new developer? So we are trying to address both sides. One is externally to tell customers, look, the tech exists for you. We're going to make it accessible to you using some of these new methods. You'll see a lot more on the AI side. Even though I said AI is not something people need to be worried about, but every FEA engineer, CFD engineer needs to use AI to be more productive than they are. And they can save a lot of time doing that because that knowledge and know-how that existed are with people who may have already left the company. That's where AI helps you as your agent, as your assistant, not necessarily to replace you, but make you a supercharged. So that's kind of the transition we're doing. And the first step in that journey was to get Apex and Nastran together. Say, hey, let's expose this. We still have some more work to do. And you will start seeing that where, okay, Apex will become a fun tool to use because it will be a self-help, self-learning tool where anybody who has the FEA background, that is a requirement. You need to understand FEA to run a tool like this. It's a specialist tool. But then we don't want you to be spending time to say, hey, where is this Nastran keyword? What is the solution sequence? Where is this modules available? So that's where these are productivity tools we can start assisting with to kind of change the let's say, the perception of the tools. And we are seeing that already, both with Adams and with Apex and Nastran. When people see this to say, wait, I can do this. That's the reaction. I think we have to get more of that out of customers.
Usability, allowing people to take full advantage of the technology that's been developed.
One here, I think, something you may know of here also is what our academic team is doing with the student ambassador programs. They're trying to get these tools, these, let's say, more fun modern tools into the hands of students so they can start learning FEA. Because at the end, that is the greatest asset they can walk out of school, is a tool that helps them design and develop products. AI is also part of that tool, but it's not the only thing. That's how I look at it.
You talked a lot about some of the development that's going on with Apex and Nastran and some of the tools that Hexagon are developing. What other kinds of innovation can you tell us about?
So, Steph, of course, I'll disclose things that are already public, but there's a lot more that we are working on that we can't share openly yet.
Okay.
But the one that I'm particularly proud of is an announcement we made at the Turbo Expo last week. It's been so we've had a long-standing, working relationship with some of the airframe companies, and it was great to see that the consortium that we planned on around rotordynamics with Boeing was finally made public to the world. And it also, is a testament to how we want to work in the future with our customers. We all know that an airframe company has to work with an engine company, whether it comes to new generational planes or engines. And tools like Nastran are really the glue. It's not just for certification, but also for virtual verification and validation. But as the engine requirements change, of course, the program requirements have, for us to meet the program requirements, software has to change and adapt to that. So some of the requirements that are coming out from rotordynamics are moving away from, let's say, pure 2D type workflows to more 3D modeling of the entire aero engine, and being able to provide those blocks to the airframers so they can start incorporating that. So essentially for things like fan blade out. If you have a fan blade out, or FBO, as you probably may or may not know, for me it was new, is when an engine fails, the airframers have to still make sure the plane can land safely at the nearest airport. So for that, they have to be able to model that entire scenario and actually land the plane. So it's awesome to get exposed to the engineering requirements and then work with our collaborators in the consortium to see what do we do to take Nastran there. It requires a lot of nonlinear dynamics, post-processing, pre-processing, etc. And the consortium that was launched is exactly to address that for aerospace companies, for aero engines. But we see a lot of proximal benefits that the automotive guys and the energy guys, especially let's say wind turbines, etc., will benefit from. So people talk in software about CI/CD or continuous improvement and development. For us, this is continuous innovation. People are using our products. Can we change the product or introduce new innovation directly into the product, or even do it the way we actually did it with Sol 400? Sol 400 has been in the market for a while, but with the new NLPerf solver, which...
So I just want to say, so Sol 400 is the Nastran advanced nonlinear capability, just in case anybody...
Thank you very much.
Okay.
This is what happens when you're in that world. You forget what it's for. So it is the advanced nonlinear for Nastran. And again, when I moved to Hexagon, I didn't even know there was an advanced nonlinear solution. So what we did was, that's another big piece of innovation that was introduced to the market, was to say, hey, can we take this Nastran approach to nonlinear, but feed it with all the hardcore nonlinear technology we have already for 40 years. If you think of Mark's base, it started when some of the other nonlinear FEA code started. Same base, same approach.
Yeah.
And now can we feed that in? And the new solvers are actually pretty amazing. It's that we're getting 2x, 3x to about 7x improvement in performance already for jobs that used to run with the old Sol 400. But more importantly, the framework is there now to say, hey, I want to add more advanced nonlinear into Nastran, whereas let's say I want to do ablation analysis and couple that with air elasticity. The framework is there now. We just need, instead of implementing everything, it's like, okay, now let the customers tell us what they want on the nonlinear side, and we'll work on that. So these are some of the innovations that got exposed. One that you will like in particular because of your Apex, let's say, leanings, is, we've exposed all of Nastran in Apex. It took about 18 months to get there, but what I mean by this is you're talking about 2,000 keywords, solution sequences, case control logic, a lot of stuff. And Apex is known to be very user-friendly, to strip away some of the Nastran-esque language. So it took, clever design and architecture to get there. And you'll start seeing some of these, more and more of these innovations coming into the hands of our customers and users. With a single purpose, is that they have a job to solve, which is to be more productive for their product development. So I go back to what I started with. How can I get you there faster? And that's really our mission right now, is to just hunker down, work on things that matter most to our users, and give them the tools they need to be productive. And at that same time, focus on these innovation projects.
That's raised a question in my mind when you talk then about the Nastran keyword functionality being made available within the Apex framework, so you can add more stuff more easily. You've got that foundation in there. So when Apex was first spoken about, maybe 6, 8, 10 years ago,
Yeah.
I remember thinking to myself, what market, but maybe market, not well, what area
Yeah.
is Apex aimed at?
Yeah.
Is it aimed at the sort of SME type company who's outgrown SolidWorks simulation, for example?
Yeah.
Or is it aimed at like you say, a hardcore, really involved, complex physics environment, jet engine development, for example,
Yeah.
or somewhere in between? What would you say on that? Where
That, Steph, that's an excellent question, because I think every CA vendor has been trying this, right? Is to say, how can I create something that is more, let's say, anchored on design, and you do some simulation with it. Whether it started with topology optimization. Hey, let me do generative design. Let me do additive manufacturing.
yeah,
Blah, blah. But the core of, again, I go back to what I said earlier, is that core of product development depends on the accuracy, the robustness that these high-end solvers, whether it's from us or anybody else, brings to the market. And that today, for the most part, the way it gets used on people's desktop is through a very text-based, keyword-centric approach. What Apex did was solve the direct modeler issue 10 years ago or 8 years ago, as you said, right?
yeah,
By saying, I'm going to make it much easier for you to take a CAD and mesh it, do mid-surfacing, do all the ties, etc. People loved it.
yeah,
But then when they were using the solution side, there were limitations, right? So not all of Nastran was exposed to that, and not nonlinear was exposed. So you really couldn't get out of that, let me say, a glass ceiling, right, with the use of FEA to say, yeah, I can address a certain market, which again, by the way, let's call it designer market, SMB, whatever you want to call it. But I can't break into and do the things that I really need to do. If I'm a tier 2 supplier or a tier 1, I still have to work with the OEMs to give them stuff. And if my tool is a designer tool, people are always going to question, okay, is this the right tool? Does it have
yeah,
the legacy? And the benefit that tools like Nastra and Mark bring is that for people have been designing aircrafts for 60 years, planes, let's say automobiles, 60 years using tools like Nastra. Same for Mark. If you think of all the advanced remeshing stuff that it can do when it comes to nonlinear analysis, it's validated, tested, verified. Gazillions of products are in the market using these tools. So why waste that, right? Why
yeah,
invent another new FEA tool? And that's kind of let's say, pivot. Think of us as like a giant startup now looking at things and saying, hey, what would we do if we were a startup? To say, yeah, we made some choices. Now let's bring them together, because the one thing that is, I think, certain for us is FEA is a sticky product. It's not going to go away anytime soon. Because again, engineering depends on it. Whether you want to send somebody to Mars or you want to put them in the next EV, you'll still have to design for a car that meets, standards or a space launch to happen, right? So you still need engineering. And we're just trying to make sure we see the new needs, requirements, which are essentially a modern tool like Apex has, but then blend it with, let's say, deep tech.
yeah,
Tools
yeah,
like now, more things are needed. I'm not saying that's the end of the world, because you still have to do your design optimization. You still have to do machine learning. You still have to do surrogate. And at least in Hexagon, we have those building blocks already, because I'm sure you've heard of Odyssey, which can create surrogate models out of Nastran. And in fact, I should have mentioned that also. We did make Nastran fully compatible to machine learning by introducing smart super elements, where you could literally create a super element, which is smart in the sense that it's parameterized. It can be fully recovered if somebody wants to recover all the internal data, but you don't need to necessarily, and you can hand that off to an engineer, a regular engineer, not an CAE engineer, and say, hey, you need a nonlinear bushing, take this and put this into your, let's say, bigger, broader assembly of, let's say, parts you have. So productivity at some point is going to be automation, design optimization, machine learning, AI. All of those blocks are there, but at least with the biggest piece of innovation we rolled out One is basically, so can we bring them together and create that fundamental layer on which we can now quickly accelerate our offers and how we go market.
Fantastic. A lot of stuff going on.
Going on, and as I like telling to the team and everybody, is that we're just getting started. So keep watching the space, keep listening to awesome, say champions like you who want to take the message out to customers. Again, thank you for what you do for our customers and users with the courses that you build around Apex and FEA. I know these are FEA classes, but yes, you're using Apex, you're using Nastran, but for anybody who wants to learn FEA, I think the way you structured your class is much better than how we do it or anybody else does it. Because we are trying to sell Apex, we are trying to sell Nastran, but you are on the other hand trying to educate people on FEA using our tools. So kudos to you for the effort you do. It's and hopefully we get to see a lot more of that from you coming with using our products.
Absolutely, Subham. Well, that's been great to talk to you. Thank you for everything you said. Some really interesting stuff there, and the future is definitely something to be excited about, isn't it?
Yep.
So,
as I call it, build better, smart, solve smarter. So you've got it, Steph, and thank you very much for inviting me to this podcast.
You're welcome.
It's been wonderful working with you over the last 2 years.
Yeah, good stuff. You're welcome, Subham. Thank you.
Take care. Bye-bye.